All right, so the problem for today is number 6 on the lecture, which is the floor of x plus the floor of 2x plus the floor of x over 2 plus the floor of x squared. How many values can this achieve in the first 500 positive integers? And what we're going to do is, first we're going to call this y, just to make it a little bit easier to say. And then we know that 1 is less than or equal to y is less than 500. And since y is always an integer, if you can just briefly look at all these floors, then we know that y is going to be an integer and we don't have to worry about non-integer values. So the first thing I'm going to do is I'm going to change the problem statement when it says how many values can this attain to how many times does this change. So let's say we start at x is equal to 0, and then we have it go to infinity, and x is always positive, so we don't have to worry about negative numbers, and x can be like any real number. And so as x goes from 0 to infinity, how many times does y change? Like how many times does y increase? And basically every time y increases, it attains a new value. Since y can't decrease, every increase has to be like a new value of y. And how many times does it increase up until 500, essentially? So first of all, we can look for a value that makes y the highest possible integer below 500. And this may be 500, it may be less than 500, but we'll see first. So if looking at these four values, a reasonable guess would be x equals 20. And what we find is that when we have x equals to 20, we get y is equal to 20 plus 40 plus 10 plus 400 is equal to 470. And then if we have x is equal to 21, then we have y is equal to 21 plus 42 plus 10 plus 441 is equal to 514. So, sorry, this shouldn't say 20, it should say 21. So now that we know that x is between 20 and 21, we should narrow this down a little bit more. And the reason why is because this number, y, increases every time x hits a multiple of 1/2. And it's going to be a lot easier for us to see in what like 1/2 range. So we want to see whether x hits 500 when it's between 20 and 20.5 or between 20.5 and 21. And looking at these numbers, since 500 is closer to 514 than it is to 470, then we can reasonably intuitively say that x is in between 20.5 and 21. And especially since 20.5 is like, well, if this is root 400, this is root 441, 20.5 is closer to, like the square of 20.5 is closer to 400 than it is to 441. And that's just more intuition. So now that we know that 20.5 is less than x is less than 21, then we can use this to find our value of x. So we know that floor of x is going to be equal to 20. We know that floor of 2x is going to be equal to 41 actually, since it's greater than 20.5. Floor of x over 2 is equal to 10. And floor of x squared. And we don't really know what floor of x squared is yet, but we can find it since reasonably now we can infer that there is a possible x such that this sum y is equal to 500. So if we have 20 here, 41 here, 10 here, that leaves us with 429, sorry, not 529. 429 for our floor of x squared. And that means that x is equal to root 429. And that's like, I mean, x doesn't have to be root 429. It can be slightly bigger than that. But root 429 is the first value of x such that y is equal to 500. So now we need to see when we have an increase. So now we have a bound on this. Instead of saying x goes from 0 to infinity, we can say how many times does y increase as x goes from 1 to root 429. And first we need to see at what points does y increase. So since these all have similar forms, this is just x, this is a multiple of x, this is also a multiple of x, we can group these into one thing. And whenever this thing will increase whenever x hits the multiple of 1/2. So whenever x is equal to 1/2 times n, where n is an integer, then this whole first part will increase. And that's pretty obvious because, well, whenever the x increases and the x over 2 increases, the 2x will also increase. So these are kind of contained within each other. So when x is a multiple of 1/2, then this whole left part will increase. And that's the only time this whole left part increases, and you can see why. And when x is a square root, then the square term will increase. The x squared term will increase, because that's when the x squared term hits a new value. And the overlap of this is when both of these are actually integers. So when 1/2 times n is an integer and root of n is an integer, then these two will kind of like quote unquote collide. So the easiest way for us to handle this is just to only count the integers once. So what we do is we'll count this first. When x increases from 0 to 429, it's pretty obvious that there will be 429 increases. And then this, we will take this, all the multiples of 1/2, except we will get rid of integers. So we're only counting 1/2, 3/2, and so on. And since we know that x is bounded between 20.5 and 21, then we know our last one is going to be 41/2. And this is 21 terms, 21 increases. So our total number of increases is just going to be 21 plus 429 is 450, and that is our answer.